Welcome back. We're now going to move on to our next step in studying earthquakes, and that is the actual lab itself. In this lab, I'm going to have you, in a few moments, build a structure of some kind on a hard surface. Could be a table, could be a large book or a cutting board, in the kitchen. Any kind of a hard surface that you can actually do a little bit of shaking and simulate an earthquake. Okay, so if you would, let's go through these directions and follow carefully, always keeping safety in mind. That's the most important thing. Okay, so you're going to build, observe what happens during earthquakes, and eventually bring it all down, destroy the structure. It's a tragedy in the real world when these things happen, but by practicing, we learn a great deal about how earthquakes impact our human culture. So let's take a closer look. Here's what I would like you to do for setting up. First off, gather some simple household items. If you have children's bricks, the bricks that kids build things with, that's a great choice. You can see in the background there, I've created an example of a structure that I could pretend to subject it to some earthquakes. That's one option. Okay, so if you have that, that might be your best option, is to use these bricks to build some kind of a structure. Or find some simple items around the house. This is an old box that's empty and not being used. Here's a cup. It's not going to break. No problems, right? Now, I could build a structure from simple household items, right? I've built, look, the top of a water bottle. That's a neat little topper for my tower. And I've got something I can test and see how it shakes and comes apart, right? Okay, so my point here is you can use any kind of simple objects around the house to build some kind of a structure. The one I'm going to go with today, you see I've used paper cups, an empty box, plastic cups, and this cone that I just found in a cabinet in the back. All right. So that's what I will use today. Whatever you use, it'll work just fine, I promise. Okay. Next, I would like you to either print your lab paper. I'll insert the document here. It's also going to be at 2.12, which is the assignment itself with the directions and another copy. So print this if you can, or pick it up at school if you want to get a hard copy at school, or just have a piece of paper, notebook paper, right? 3-hole punch paper, and you can easily just write down the parts that you're going to fill in. We'll go through those in just a moment. So print it if you can, but you don't have to in order to still succeed on this lab. Okay. Check in with mom, please. Make sure it's okay with mom that you're doing something at maybe her kitchen table or whatever. Include your mother in this process. Don't just assume, oh, Sandrock's telling me to do something, so I can go and wreck the house. No, Sandrock did not say wreck the house. Please check in with mom or dad and make sure they are okay with you building something simple out of non-breakable objects, and you have a place to simulate an earthquake, right? Without doing any damage to anything. Don't scratch the floor. Don't knock off something breakable. Please be very careful. Consider your parents' wishes first. Okay. If you don't have a table that is easily usable this way, use a large book. Use a cutting board from the kitchen. Use some kind of a hard surface, a piece of cardboard even. You can build something on and give it a shimmy, shake, and see how the structure holds up. It's only up to your creativity how you can make this happen. So, and then last, before you begin even writing your name on this thing, clear the area of anything that can be broken, knocked over, shattered, lost, whatever. Just clear the area, think safety, and you'll be good to go. Okay, here we go. Let's talk about how you're going to do this thing. All right, safety first. Dangerous activity, horseplay, fooling around. If a little, brother or sister runs in the room and flips the table because it looks fun, you have to manage all your risks in the area. Please make sure you're being very safe about this so you don't ruin the exercise. All right, safety is the most important thing, like always in science. Okay, so you've got your lab paper, or you can read it right here on this video, or you can bring it up on your screen. Pause me here, read all the directions, and I mean from the top down to number 5. Go ahead and pause the video, read through those things so that we review what we're going to do. Okay, go ahead and please do that now. Okay, if you have read 1 through 5, you can see it right there. You can see it right there next to me, 1 through 5. And then if you understand what is there and you're comfortable with being safe and building something out of your household items or play blocks or whatever it is you're using, then you're going to decide, what kind of structure am I going to build? It can be a bridge or a house or a skyscraper. I don't even know what this is. Maybe it's a fancy bridge with towers holding up, the cables, and it's a bridge going over some water. I'm going to call this a bridge. Okay, so I'll just do that. I could even call it a skyscraper because it's tall vertically and it has multiple levels. Maybe I'll call it a skyscraper. But whatever I've built here, that's going to be the building that I subject to the earthquake. Okay, so once you decide what you've built, let's go ahead and move on to the next thing. So we're going to do some planning and some building at this time before we even think about doing an earthquake. Don't test an earthquake just yet. So this part of your paper here, you see it on the screen, or right there. Everything's backwards. You see it on the screen right there. You're going to build the structure and also sketch it in this box. So if I'm sketching this thing, it might look like that. Okay? Is that pretty accurate? Feels pretty accurate. I don't know. It's close, and close is good enough. So I can see when you turn in your lab report, what did you build? Was it tall and slender? Was it short and spread out? Or was it something in between? Sketch your structure, make it simple. Okay? Then we're going to go through and figure out how many people are in your structure. If you built a bridge, is it rush hour and there's 80 cars on the bridge? Or if it's a skyscraper, was it the middle of the day and there's 1,000 people in the building? Or was it the middle of the night when the earthquake struck and you only have 20 people in the building? Whatever, you decide. If it's a house, please don't put 1,000 people in a house. That's ridiculous. Okay? If it's an apartment complex, maybe 6 or 8 families. Okay, if it's a lot of apartments in an apartment building, you decide how many people, but make it match reality, make it real. Then, letter C, if your structure is the real thing, how many floors tall is it? I'm going to call this a skyscraper. So I have checkmarked skyscraper. I've decided that in my skyscraper, it's early in the morning, not quite everybody is there yet, so I'm going to put 150 people. You decide your number, don't pick my number. And I'm saying mine is 10 stories tall. So there's 3 stories of structure, support, there's 3 stories of working space, and then there's another few stories on top of that of towers and rigging and so forth. So I'm going to say this is 10 stories tall, and I'm going to write down 10 stories tall. Okay. Now let's make some predictions. Again, I haven't shaken a thing yet, but I'm going to look at this and I'm going to predict. Will it withstand minor tremors? Let me show you what a minor tremor might be. This is a minor tremor. Okay? I used this as an example. I shook it a little bit. Nothing inside really moved. This shifted around a little. So did it still stay intact? Yes. So I'm going to predict that my structure, it will stay intact. Yes. But a major quake, like if it really shakes and violently tosses everything around, I think this thing will fall apart in pieces. So I'm going to predict, no, it will not withstand a major quake. And you circle whatever you believe, whatever your predictions right there, if you say yes or no. Now, I'm going to make another prediction here. It says, which part will have more damage? The top or the bottom? And you kind of have to decide which one is going to have more damage. Make a prediction. I'm going to guess, not knowing what will happen. I'll guess the bottom. I'll say the bottom will come apart, and then the top will eventually lose. But I bet the bottom will come apart first. That's my prediction. But who knows if I'm right? We'll find out. Last prediction. Will we have injuries and deaths if this thing collapses completely? Yes, I predict the people who are on the top floors will probably not survive. People on the bottom floors might have injuries. If they're able to make it out, they'll still have some injuries. So I put yes, I think there will be injuries and deaths if this were the real thing. Okay. All right, come on, light, come back on. I lost my light in the room. Okay, I think you can still see me. I'll continue. Okay, so at this time, go ahead and do your building. Pause me here until you've created your structure, until you have completed your sketch, and make sure everything on the front is answered before turning it over to page 2, where we'll do some tremors. Pause me now. Finish page 1 completely, okay? Okay, so if your structure is built, you've made it, you've sketched it, you've predicted, you've described how many people and how tall it is, you've captured the idea of a building in the real world. Now, time for us to see how well it stands up. So, let's go to side 2 now, please. And number 8, let's read this together. Please read it with me. This is probably the most important part. Number 8, please read and follow for safety. Please be gentle. Grip the table or whatever hard surface you're using, and don't let go while simulating earthquakes at your table. Don't flip the table. This has happened before, my friends. The first year I did this exercise, instead of doing as he was instructed, gripping the table at the end and not letting go, he gripped it on the side and flipped the table. He got a little too energetic, flipped the table, pieces of blocks went flying across the room. We got lucky, nobody got hurt, but he kind of ignored his safety briefing. That's why I spend a whole slide just on safety. Please focus on safety. Nobody gets hurt doing this exercise, okay? Don't flip the table. Don't break anything. Again, check in with mom and dad. Make sure they're okay with your plan and that nothing gets broken and no one gets hurt. Okay. All right. Now, time for us to create some tremors. First, very gentle, and then we write a few things down. Then a medium quake like the one we felt in March of 2020. That medium level quake, we're going to do some medium level shaking here and write a few things down. Then at the end, we give it a major earthquake, the kind that destroys cities and knocks down mountains. Okay, we'll do that at the very end, but only after we finish writing down part 1, part 2, and then we get to part 3, which is number 11. Okay, so let's go there right now. Starting with the minor tremor, okay? Take a look at your directions. Again, it says exactly what to do. Do exactly what's on the paper and that I tell you now, and you're going to be okay. Number 9, minor tremor. Directions. Make 3 gentle pushes to your table. Remember the slinky and how I hit it and it did a push wave? That's what you're going to do first, a push wave at the table, okay? 3 little pushes. Minor tremor, hardly there. Okay. So I'm going to show you what that looks like, and then you're going to write down your observations. So observe. Now the lights come back on. Okay. I've got my structure. I've got my table. I'm going to grip the table at the end, not on the side, but at the end, and I'm going to give it 3 little pushes. Watch. 1, 2, 3. And I'm done. Now, what did I observe? Okay. I saw the top part shifted, it swayed, these parts moved, this cup actually moved forward, that part actually moved back, okay? This one stayed put, but it tipped and rocked a little bit, okay? You can go back and watch it again if you want to see what it did. That's the beauty of, if you have a cell phone, you can record it, maybe on slow-mo, right? If you have that, you can see what really happened. And you go, oh, okay, this is what happened, and you write it down, okay? My notes I took down, the highest parts moved a bit, but it stayed standing. It did not fall to pieces with just a little quake. So I circle the intensity of the quake, circle a number, 2 through 8. I think that was like a 3 maybe. The highest parts moved, but it stayed standing. I've written that all down. Okay. Letter C. It says rebuild or repair any damage if you wish. If you want to rebuild it and put it back the way it was, be my guest. I'm going to put this cup back where it was. Okay. Repairs are complete. Have I finished part 9 completely before going on to number 10? Looks like everything on my paper is done. Make sure your 9 is finished before you go to number 10. All right. Let's go now to number 10. Okay. 10 is, I'll stay on this slide. 10 is a mid-range quake. The directions say make 3 medium pushes and 3 sideways shimmies. Remember the slinky. The first one is a push. The second one, side to side, just like the S wave, that snap side to side that I did with the slinky. Here we go. Okay, so mid-range quake, 3 medium pushes, 3 sideways shimmies. Now let's make our earthquake. Here we go. Got my structure. And my first thing, what does it say? 3 medium pushes. Okay, here's my 3 medium pushes. 1, 2, 3. Ooh, the top parts came apart completely. But then it says to do 3 side to side. 1, 2, 3. Done. Okay. My structure started coming apart, even in a medium quake. So, whatever you observe from your medium quake, you're going to write those sentences down in that space. I've just got a squiggle line filling that space right now. Circle how intense you think it was. I think mine was a 5, so I circle 5. Full sentence. During the medium quakes, what damage did your building have? I would put the top of the structure failed completely, but the bottom stayed intact. Did the push quake or the sideways quake do more damage? In this case, the top of the building, the push did the damage, and the bottom really stayed intact. The sideways quake really started pulling the foundations apart. So this may be a tower that fell down, but the real damage to the building, when it started cracking and crumbling at the base, I'm going to say the sideways did more structural damage, even though the top falling off was more dramatic. So I'm going to put sideways because that's just my interpretation. Write down your answers. And then it says rebuild and repair if you wish. So pause it here until you're completely done with number 10. I'm going to do my rebuild. Did I get it right? Looks pretty good. Okay, my structure is rebuilt. Okay, number 11, major temblor, like violent earthquake. This is a temblor. This is a big deal. Let's follow the directions exactly. Make 5 sideways shimmies. Again, now side to side. No more push. It's now side to side. Those shear waves, those S waves. And 5 3-inch up and downs. My friends, please do not lift the table up to your chin and drop it on the kitchen floor. Mother would kill you, and then she'd come and kill me. So please don't do it. So observe. Watch my example before you do this at home, please. Safety is the most important. This is where if something's going to go wrong, if a student, I don't know, flips the table, this is the one where that happens. So please pay close attention. Watch. 5 sideways shimmies, 5 lifts up and down. Keep a grip on the table. Don't just let it go. All right. Sideways shimmies, 5 of them. 1, 2, 3, 4, 5. That was dramatic. And 5 lifts. Again, I'm only lifting it 3 inches, not 3 feet, 3 inches. Observe. 1, 2, 3. That was big. I lifted it, but I kept control of it. I didn't drop it. I didn't break any dishes in Mother's kitchen. But my structure came apart completely. Okay, time for observations. Full sentence. During the high-intensity temblors, what happened to your building? My top structures failed completely. Every tower fell right away. Then the foundations failed, and even the middle level came crashing down. Boom, done. I've described what I saw in a full sentence, from start of the shaking to finish of the shaking. Sideways and lifting. S waves, L waves. Did the sideways quake or the lift and drop do more damage? You decide. You saw how your thing fell apart, your building. You decide. Why is that? Ooh. Come up with a full sentence describing why you think the sideways did more damage or the lifting did more damage. You decide. Give me a full sentence explaining why you think that one did more damage. Okay? All right. Go ahead and pause me there until you're done with number 11. Okay. When you're ready to do your conclusion, we're home stretch now. We're almost done. Number 12. Based on your conclusions, what number of casualties means injured, dead, or missing, that's the word casualties, were during all these events combined. Okay? So minor tremor, medium quake, major temblor, all those events combined, how many people were injured in your structure, how many people were killed, and how many are missing? It's handy to go back to the number you started with. Me, I started with 150 people. Maybe yours had 10 people, maybe yours had 1,000 people. You decided, right? You already picked that number of people. How many of those people are dead? Put the number. Injured, put the number. Missing, put the number. Please make sure all these don't add up to way more than this. If you only had 150 people in the building, but 1,000 people went missing, go back and check your numbers. Make sure you're doing it right, okay? Final step in the conclusions. Take a look. From what you have seen, how should real buildings be built to stand up to earthquakes? You saw your building come apart in pieces in its own way. If it was the real thing, what do actual engineers have to do to make that building survive? Full sentences. Don't just put make it stronger. That's not enough. Give me specifics. What should builders keep in mind to make structures survive an earthquake even better than they used to? Okay? Once you've finished your sentences, let's see the last thing it says, save or take a picture of your work, submit it in Canvas, okay? Or send it to me in an email. You could do that as well. Or bring your completed paper copy and drop it off at the school sometime. You don't even have to come to my classroom. Just drop it off at the front and maybe put my name on top for Sandrock. Boom. And they'll get it to me in my mailbox. Okay? So you got lots of options. Try and get this thing done as quick as you can. Okay? I know we're in February. By the end of the second week in March, that's this year. Future years may be a little different on the timing, but make sure you get this done before our quarterly deadline. After the quarterly deadline, there's not much I can do. It is what it is, and the grade you've earned is what you've earned. So make sure you get this done, turn it in to me, be proud of your work, and hopefully you had a little bit of fun along the way. Thanks for doing science with me today, and let's do it again next time. Coming up next, mapping the ring of fire, and then after that, diagramming the layers of the earth. Pretty cool stuff coming up. So dive into those as well, just as soon as you're done with this. If you've got time, press on forward, press on with pride, and take care and be safe. Thanks, you guys.